Today we're going to learn about solving systems with three equations and three variables. In order to really understand this particular section, you need to have an understanding of how to solve systems of equations where there's two variables, which we worked earlier. If you're not familiar with those, you need to go back, make sure you know how to solve those equations before you come to the systems of three equations. Because in the systems of three equations, we're going to use the same basic process of either substitution or elimination, perhaps even both, to solve the equations. When we have a system with three variables, you need to be able to solve for each variable independently. Your answer is going to be what we call an ordered triplet. When we have systems with two variables, we had an ordered pair. This has three variables, so it's going to be an ordered triplet. When you write your answers, you need to make sure that they are written in alphabetical order. So your x value comes before your y value comes before your z value. If you have variables of a, b, c, the a would come first, b second, and c would be listed third, regardless of the order in which you actually solve them. When we have systems of three equations, it's going to deal with more of a spatial or a three-dimensional concept or idea. When we solve systems with two equations, where we had two variables, we had lines that were crossing. These are three-dimensional, so they're going to be planes that are crossing. And we can have various solutions. We can have one solution, we can have infinite solutions, or we can have no solution at all. And I'll show you that as we go through the process. So let's begin with an example. Let's say I have 3x minus 2y plus 4z equal to 35, a second equation of negative 4x plus y minus 5z equal to negative 36, and a third equation of 5x minus 3y plus 3z equal to 31. The basic idea is I want to eliminate one variable at a time until I have only one variable. I can then solve for that variable and then use substitution as we go through and work our way backwards to solve for the other two variables. Given these three equations, what I'm going to do is I'm going to solve for y first. If you look at this second equation, we see that y has a coefficient of 1, which means I can very quickly and easily solve for the value of y by adding 4x to both sides and 5z to both sides. When I do that, I end up getting an equation that y is equal to 4x plus 5z minus 36. I can then use that value of y and substitute it in the other two equations. Here I've got a y in my first equation, here I've got a y in my third equation. But instead of using the y, I'm going to use what y is equal to, which is this 4x plus 5z minus 36. So by using substitution, I get my red equation being what is seen, and then my green equation when I substitute in that value of y. The next step would be to simplify this, mainly by distributing. So if I take that red equation and I distribute that negative 2, make sure you distribute correctly. We want to make sure that negative 2 times 4x gives you negative 8x. The negative 2 times 5z gives you a negative 10z. And the negative 2 times negative 36 gives you the positive 72 that you see in this portion of the equation up at the top. I then simplify that down, giving me the negative 5x minus 6z is equal to negative 37, and negative 7x minus 12z equals negative 77. So now I've got a system with two equations. These we have worked on before. So what I'm going to do is I'm going to eliminate one of my two variables. This time I'm going to use the elimination method by adding and subtracting. In order to get my z values to have the same coefficient but opposite, I'm going to multiply that first equation by a negative 2. That gives me 10x plus 12z equals positive 74. The green equation I'm just copying down. Now when I add those two equations together, I've got the 10x minus the 7x, which gives me the positive 3x. The positive 12z minus the 12z cancel out. And then the 74 minus the 77 gives me this negative 3. Then I need to solve for x by dividing both sides by 3, which gives me x equal to negative 1. Now that I know that x is equal to negative 1, I can substitute that into one of my equations. Now, of the top two equations, which equation would be easiest to use? I think the red equation would be easiest to use because they're all positive values. I don't have to worry about the negative signs. So I'm going to substitute in for my x value in that top equation. So that gives me 10 times my value of x, which is negative 1, plus 12z is equal to 74. Distributing that 10 times negative 1 gives me negative 10. Adding 10 to both sides gives me 12z equal to 84. And then dividing both sides by 12 gives me a z value of 7. So I now have two of my three variables solved for. X is negative 1, z is a positive 7. Using the equation from the previous slide, where I had y is equal to 4x plus 5z minus 36, I can substitute in my value of x and my value of z. My value of x, again, was negative 1. My value of z was 7. Substituting that in, distributing, combining like terms, I get an answer of y equals negative 5. So my final answer is going to be negative 1, negative 5, and 7. Make sure you put them in order. My x comes first, followed by my y, followed by my z value. Same as in the alphabet. So even though I solved for x first and then solved for z, my z value needs to be the last one listed because alphabetically it comes last. After we're done with that, we would, if time permits, want to substitute in these values of x, y, and z into the original three equations to make sure they work for all three. In this particular case, they do. That brings us to the question of how do I know whether an equation is solvable or not? Well, as we go through the elimination process, if we get something that is false, such as all my variables cancel out and I'm left with just constants, where it says something like 0 is equal to 5. If that happens, there is no solution to your systems of equations. If you happen to have something where all the variables cancel out and leaves you with something that is true, such as 0 equals 0 or 8 equals 8, then you could have infinite number of solutions, but you're not going to be certain until you do another process. Let's just say I had three equations. I'll call them equation 1, 2, and 3. Of my three equations, let's say those first two I used and I eliminated my z value. And it gives me something like 0 equals 0 when I do that. Well, I don't want to stop there. I need to keep on going. I'm going to use maybe equations 2 and 3 and eliminate the same variable. I could also use equations 1 and 3 and eliminate the same variable. If I eliminate the same variable and I end up with something like 0 equals 0, or if I end up with something that could be true, such as 3x plus 2y is equal to 14, then I can assume I have an infinite number of solutions. If I get an equation such as 0 equals negative 5, like what we saw up here, then that would tell me that there is no solution. So how do I know if there's an infinite number of solutions or no solution? There'll be an infinite number of solutions if you get 0 equals 0 and some other true or possibly true result. You'll know that there are no solutions if you get a false statement such as 0 equals 5. Let's try some. Let's say I have these three equations. What I would like you to do is you can pause the video and go ahead and try to work this out, try to eliminate, and so that you can follow along with me here, the best one to eliminate would be z. So the next step that I took was eliminating one of my variables by solving for z. I use the green equation to solve for z. Go ahead and pause the video and do that. When you've done that, you should have had z equal to negative 5x plus 3y plus 17. So ask yourself, what do I do now? Well, now that you've solved for z, I'm going to substitute that value in the red and the blue equations. So pause the video and go ahead and do that. After doing that, you should get these two equations here. What would you do next? Distribute. So go ahead and pause the video and distribute those equations out. Once you've distributed, you should have these two equations. What would be the next thing that you should do? If you said simplify, you are indeed correct. So go ahead and take those two equations and simplify them. Go ahead and pause the video until you're done there. Now that you've simplified them, you should get 27x minus 11y is equal to 103, and negative 13x plus 11y is equal to negative 61. So now you have a system of two equations. What do you do next? If you said eliminate the y variables by using addition, that is exactly what I would do. They have opposite values, and therefore they're going to be very easy to solve. So go ahead and eliminate the y value. Upon doing that, you would get 27x minus 13x gives you 14x. The y's cancel out, and you have 103 minus 61 gives you 42. Dividing both sides by 14, you should get x is equal to 3. So now that you have solved for one of your variables, what is your next step? Your next step is to substitute that value of 3 into one of the other two equations that you have at the top of the screen. One of these two. Let's use the red one. Go ahead and pause the video, substitute in your value of 3 in the red equation. After doing that, you should have 81 minus 11y is equal to 103. Subtracting 81 from both sides and then dividing both sides by negative 11, you get y is equal to negative 2. You've now solved for two of your variables. What you can do now is use this equation that you solved for z and substitute in your x and your y value, or you can go up to one of your original equations and substitute in your x and your y value in those equations to solve for z. I chose to go ahead and substitute in to the red equation. When I do that, I get 2 times my value of x, which is 3, plus 4 times my value of y, which is negative 2, minus 5z is equal to 18. Distributing, combining like terms, and then dividing, I get z is equal to negative 4. So my final answer is 3, negative 2, negative 4. Again, I need to put those in alphabetical order. In this particular case, I did solve them in alphabetical order, so that made it easy, but we do want our final answers to be written in alphabetical order. Let's try another example. Here, I don't have a particular variable that has a 1 or negative 1 as its coefficient. So I am going to default to elimination. Let's eliminate the x variable using the blue and the green equations. Go ahead and pause the video until you have that done. If you did eliminate the x variable, I would need to multiply my blue equation by 3 and my green equation by 2. After adding those two equations together, I get 0 is equal to 0. So that means I do possibly have an infinite number of solutions. So what do I need to do next? Well, I can't stop there. I've got to eliminate the same variable using two different equations. So in my original, I used the green and the blue equations, equations 2 and 3. Now let's eliminate the x variable. Let's use the first and second equations to eliminate my x variable. Go ahead and pause the video until you have that done. To eliminate that variable, I would need to multiply my first equation by 4 and my second equation by 5. When I add those two equations together, I get negative 34y minus 60z is equal to negative 120. Now I can stop there because of the first instance where I have a possible number of infinite solutions. Once I have something that could be true down here, eliminated in the same variable, I know that I have an infinite number of solutions. In this particular case, the planes would all intersect and they would have an infinite number of solutions. If we work out this system, I look to see if I have any variables that are easily solvable. There are no variables that have a coefficient of 1 or negative 1, so I'm going to use the elimination process. I am once again going to eliminate my x variable. I am going to use the second and third equations in order to do that. So pause the video until you have eliminated your x variable. In order to eliminate, you need to multiply that second equation by 5, and then I just copied down the third equation. Adding those two equations together, I get 0 is equal to 5, which means there is no solution. I do not need to check anything else. I can stop right there with no solution.